Hey everybody, I'm Jonathan from Autodesk. Welcome to Shop Talk, the podcast series where we get together with makers, engineers, and designers from shop to shop. We're doing another tour today at Cascadia Structural. I'm really excited about this one because you're about to see the biggest CNC machines you've ever seen. Kyle.
Hey.
Hey man.
How's it going?
Good, thanks for having us.
Yeah.
Can you tell us who you are and what you do?
Yeah, so my name's Kyle Gilham. I am the product development director here at Cascadia Structural Timber Solutions. We use large format CNC machines to go ahead and cut timber trusses and produce material for job sites.
So we're gonna get a tour of your amazing facility over here and basically just follow the material from delivery to shipping and see every step of the process and all the cool stuff you do.
Sounds great.
All right.
So this is our custom machine that we'll use for any type of custom job. So if you can't fit on one of those machines and we don't want to hand fab it, we can do it on this. So this can do, I think we've done up to 6 feet deep beams on it.
Wow.
Here you can see some of the other stuff that's getting packaged up, ready to leave. So this is actually trusses that were broken down. All your steel and hardware gets delivered here. Paint, we're starting to do some sealant as well. So all the paint and sealant will come in here. So a lot of times we're starting to add, it's kind of like a construction sealer, which basically just protects the wood until it can get dried in.
Sure, okay.
So we're starting to do that, but that's where all of our shipping and receiving comes in.
Okay.
And then once it's been checked, it goes onto the racks here. So here you can see we've got racks ready to go onto our K2 machine. This will already have all the cam done on it in the office before it actually comes in. And so once they're ready, they'll go ahead and take it off the racks. You can see he's loading up these beams now.
Yeah.
They're gonna run through the machine after he loads it up, and then your finished material happens over here. Here again, you can see we add some tags to go ahead and track. So once it's here, there are certain numbers, but a lot of these are gonna be similar fillet size. So those probably are semi-interchangeable maybe, right? And so the idea is they're not necessarily labeled all the same or uniquely here, but once they come off the machine, then it's a unique part that's gonna go specifically somewhere in the building. So we need to add that unique part number on. Yeah, so this one will do 18 inches wide by 2 feet deep. We've done everything up to 80 feet. That gets really tricky because you got to lower those gates.
Yeah.
So you see the red gates.
Move the trailer out of the way.
Yeah. The red gates can actually lower to make you do longer. It just slows the machine down because we have seen this happen where that saw, if it's doing a rip cut, will shoot stuff down. So if you don't have those, it slows it down so it can't.
Yeah.
But anyway, then it's got 3-axis mill, right? So that mill, if you want to actually take a look, you can see it. So the mill can come up and down and then rotate, right? And then this can go this way.
Okay, yep.
So then you've got, what is that, 3 axis?
Yeah.
Right? So I've got a 3-axis mill.
Up and down.
That's what we call a universal mill right there. So that can do a lot of those bird mouths will be done with that.
It's like the, if you ever look inside a planer, right? It's the same thing.
Very similar.
You've got teeth on there.
And those are all extractable teeth, rotatable. And so what's nice about that from a tooling standpoint is if it ever gets dull, all I have to do is either rotate the teeth or if that tooth is now no good, I just replace
it.
Right, which is a lot cheaper than replacing the whole tool.
For sure.
And so same with that, actually, that finger mill, same kind of design. So it's still an end mill, but it's using cutting teeth, so you don't have to replace the whole mill.
Got it, okay.
And then this is your vertical mill.
Oh, okay.
So you've got a vertical one that'll just go up and down. So once it's done on this machine, you can see he's taking it off right now. He's gonna go ahead and put it over on the sawhorses over there, and that's where if any additional fab needs, you're going this way? If any additional fab needs to happen, they'll be done there. Oh, it looks like they're storing it here for right now. You can see. So here you can see they're storing it here, getting it ready for fab. So you can see all of the ones that are already done, right?
Yeah.
And they're getting ready to go.
So your connectors would be something like a Simpson strong tie. So you're talking steel plates that have holes drilled, that kind of thing, or?
Yeah, they have specific ones for mass timber that take into account fire rating.
Okay.
So with fire rating, you need to have it protected in the wood because the wood chars and actually protects the steel, which is kind of ironic. You would think it's the other way around, but
yeah, it's going to sound kind of counterintuitive that for fire rating, the thing needs to be surrounded by wood. Yeah. I remember in architecture school learning about how wood, like in mass timber anyway, is far superior for fire performance than steel is.
Yes.
It doesn't make sense to you because you think of wood as burning, but the mass of the timber, I mean, you could have the whole building burned down and the structure's still there.
Yep, it just chars to a certain extent and then actually stops. Yeah, that's one of the perception things that they're working really hard to kind of help, get people over.
Yeah.
And then the other part is just not a lot of people design with wood.
Right.
And so there's not a lot of expertise.
Right.
So that's one of the areas that we're really trying to help with on the CAD side is how can we make it as easy to specify without you having to do a lot of this?
As like box section steel or something where you can, you've got a catalog and you go through it, your connectors, like all that stuff's there. You've got a whole book with every detail you need for that. Like that stuff maybe isn't here so much for timber yet.
Not yet.
Yeah. And the glulam beams are always continuous members. There's no like sistering going on where you have maybe like half the length. Yes,
yes and no.
Yeah.
So the full member itself, the full member itself is considered one length.
Yeah.
But all of them will have individual, what they call finger joining.
Yeah.
Yep, right there.
Yep.
So this is a finger joint, and this is just allowing that wood to be as long as you want it to be, as long as you have those. And so there's a lot of specifications around finger joining and how those get applied.
And then when you imagine a glue joint all the way down that and several of them together, it's effectively one.
It's effectively one beam.
Member. Yeah. So cool.
Yeah. Really, really interesting process.
Yeah.
So like I said, if it doesn't go on this machine, we'll use this machine that's down right now, but we'll use this machine down here. So this is our robot drive. This robot drive will do up to 4 feet deep and about 12 inches high width. So a lot of our bigger members will go through there.
And you're swapping out a servo motor on this one, I heard, right?
So servo motor is getting replaced right now on that. So like I was saying, once it comes off either of these two machines, it comes into the middle here and then gets set on sawhorses. If additional fabrication needs to happen, we have all the hand tools right here that you'll need.
So this is shipping and receiving.
The shipping and receiving. Yeah. So as soon as the job's done, it goes back out here, unless the truck's ready for it right off the bat and they're hot for it.
Yeah.
But it'll come back out here. We'll put it in a stack per job. Another reason we are FSC certified, which means that we track, if you have an FSC job, we'll track that job from beginning to end. It's pretty easy for us because we track every job like that, but chain of custody is super important for a lot of those. We had another one that's coming up, but the idea is you need to be able to track all the material through the whole process, and so that's how we do it. But yeah, so once the job's done, we'll stack it in a pile, get it ready for the truck, and then trucks load here and unload here as well. So
cool.
Works pretty well. Got about 10,000 square feet there.
Yeah.
Of loading and unloading.
Nice. Yeah, so I just kind of like to see what does a truss look like when you pull it up in Inventor. Because for people that aren't really familiar, the way this has worked historically speaking is that there's a big disconnect between the product for the building and the design of the building. The processes of designing those things are so different, and the considerations are just they're very different. If you're working in Revit as an architect, and you do you design a whole building, a wall, whatever it is, in most cases you're not really modeling the connector in the truss, for example. You're picking something, a family from a library, and you're placing those things, and then those things all go together to be your building. You're not going to model the 2x4. You have a wall that has specifications built into it, and then when you take a section of that wall, a drawing for a detail or a spec or something like that, it shows the bottom plate and the top plate and so on, and whatever's in that wall. An inventor, what you're doing as a manufacturer is you're doing all of those nitty-gritty details. So every little cut in the timber frame, every little kerf, bringing in the brackets, right? As we talked about, there may be a point in the future where you're doing those yourself, and of course you'll be using Fusion to do that and running everything on a water jet or plasma or whatever it is. But there's all the benefits of that our customers already know. But could you show us? I guess we start with let's start with Revit and see. I take it back. Let's start with Inventor and look at one of your products that's customizable.
Sure. Yeah. Okay. So all of this is driven by iLogic code. So this allows us to go ahead and make modifications that, again, are parameter driven and easy to customize in Inventor. So the idea here is that I want 4 things that the customer can change, and then everything else I want to go ahead and control myself. So a lot of this is still parameterized and controlled through parameters, but the only things I'm actually exposing to the end user are things that I want them to be able to change. So here you can see I've got my pitch that I give them 3 different options. They can change the length anywhere they want. I have a connection type that they have here, and then I have a truss style. And the truss style changes your member sizing and your bolts. So this style of truss is actually always going to be the same, and so I'm going to actually I've published 4 different styles. So this is called a Fink truss. I also have something called a Howe truss, double Howe truss, and then a scissor truss. So this one's pretty common in like outdoor shelters. It's kind of what we're looking at here. But here you can see, again, I can change this to say 55, and it's automatically going to update as soon as I pop out of there. And so the idea is, again, make it super simple, but you can also see some of the iLogic code if you ever want to run through it. Is going to go ahead and turn some stuff on and off and specify the different things. And then
the sales model, this is sort of the back end, and then the sales model is going to have the parameters that you just had up there. That's what the customer will have be able to change in Revit.
Yeah, and you can see how we publish it here. So this is Informed Design is a plugin that sits on top of Revit and Inventor, and then also has a web. You're publishing it to ACC docs. And so there's stuff happening in ACC docs as well. But from our standpoint, it just looks like this Informed Design. You see this product definition pops up this, so I can go ahead and edit, kind of show you what it is. But here you can see you've got the project here. If you have drawings, so this is the other thing that we're kind of missing right now, because we don't have everything in the single file, right? Because I have a sales model and a fabrication model. What you will eventually be able to do is all your drawings can also get published. So as soon as you update it in Revit, all of your production drawings are also ready to go and can be published while linked to the Revit model.
Nice.
But here you can see this is where all the parameters are defined. So you can see I have a lot more parameters.
Right.
But I'm only
these are the only ones that you want your architect to be able to.
The checked ones are the only ones I want them to be able to adjust. And then what's cool is you can make some rules for them that they can go ahead and see on the Revit side, right? So the idea behind this is, one, I only give them a couple different pitches. This is what we had kind of defined ahead of time. But when I was going ahead, because So these are all pre-engineered, right? So I've done the engineering for these trusses for the most part, right? And so I know what lengths are possible. And so I go ahead and make these types of rules that goes ahead and messages to the end user and says, I can or cannot do this, right? And so the idea behind this is I can't actually make a light truss that is more than 70 feet long.
Because it doesn't meet your specifications.
Well, it becomes overloaded too quickly.
Sure. Yeah.
And so we say we're just not going to do that, and you can do that for all of these. And what's nice about that is as soon as they do that, it pops up a dialog or a message box, and then goes ahead and resets it. So it doesn't actually allow them to make something that is outside of our box. So really cool, and this is a very simplified way of what we're doing. I could see it getting way more complicated if you wanted it to. Yeah, so that's pretty much it from this side. So from the Revit user side, and here's all the different things that I said I was going to give access to, right? The interesting thing about this is that you might have something that's already been created, and you can go ahead and look. So if you only need to put in an 83-foot truss, you can see one's already been generated. So what this is actually doing is this is looking back into the web portal, and it's configuring it using Inventor APIs up on the cloud, and then generating a new output that they can then use, right? So it takes a little bit of time if you modify this to go ahead and generate a new model, because again, it's having to do it all in Inventor and spit out a new model. So that's one of the things we say is like, we also have RFAs that we'll give to our customers for them to use for like initial design. And then once their design's finalized, more or less, or close to, then we say use informed design, because it's still not going to be as fast as say RFAs. Sure. Right? But the RFAs will let you do stuff that we can't do. So this gives you the manufacturing data that you need. So again, you can say 65, say 512, and then you're going to go ahead and hit generate. And it even tells you that, hey, it's going to take a few minutes. So that'll take a few minutes. You can come over here. But if you just wanted to say insert one that's already there, that's 83 feet, you can go ahead and insert that, and it'll say successfully inserted, and then you use it just like any other RFA. Yep. Right? And then you can go here, go ahead and look at it in the 3, and you've got your, just like any other RFA, and it's got all the splices where you would need the splices. So it looks pretty much like the truss you're gonna see. Again, it's the sales model, so it doesn't have all the detail in there. Sure. But at the same time, architects don't necessarily want all that detail. Right.
And this will also have data in it, like a column goes here, so that connector at the edge.
Yeah, we haven't built that part in yet. But yeah, you can build in here. The column goes there. But what's cool is I built in like a smart part number. So here you can see double how, 412 pitch, 83 feet, wood connection, and a medium truss. So that's going to change based off of your configuration that you put in. So it's updated and modifiable based off of your inputs. And that makes it easier for you to order from us, because this is a unique part number to us. Yeah, and that part number tells you exactly what you need to know about it, and you can adjust your parameters that way. And then eventually this will feed back into an Inventor model automatically, so you wouldn't even need to. Eventually it's going to be automatic. For now, it's actually still pretty easy from our side. You just go. There's only a few parameters here. There's only a few parameters, and I have a whole fab model set up that just has more information on it than the other ones, but it's updated with all the engineering facts in it as well. So here you can see if I've got my, say, like that think truss we were looking at earlier. You can open this up, and you can see it's got all of the bolted connections in it. And so what's cool about this is all of the engineering information has actually already been done. And so all of this is ready to go for the loads that we've specified for this truss.
Yeah.
So all of this has been engineered, and so it's pretty much ready to go as long as the loads are correct.
Yeah.
You know, you can go ahead and spit this out. It's even got drawings already associated with it. So all I do is this thing called an iLogic copy that copies it to the specific parameters that I want.
Yep. And the drawing updates automatically.
Drawing updates automatically, and you're ready to go. So you're talking about going from probably a week's worth of time to like a couple hours.
Yeah. Wow.
Yeah.
Well, cool. Thanks for your time, man.
Yeah.
This is super interesting.
Yeah.
I'm glad we're able to help you do these things more efficiently and faster. Can't wait to see what you come up with next.
Yeah, sounds great. Thanks for coming out.
Yeah.
Appreciate it.
Hey everyone, don't forget to like, comment, and subscribe to our YouTube channel to stay up to date with all things Shop Talk. If you're ready to try Fusion for yourself, find the link in our description.